under 8.3 and on page 153, we are told that for a discrete random variable, the sum of all the probabilities must add up to 1. And it is true because in both examples, example 3 and also in example 4, we have had that. If you look at example 3, we have had the probability of x is equals to x is equals to, when we had 1 over 6, it appeared 6 times, and therefore this is going to be 6 over 6 and is going to eventually be 1. If you look at example 4, the probability of the number of heads and the probability of x is equals to x, when we had 0, we had 1 over 8. When we had 1 head, we had 3 over 8. When we had 2 heads, 3 over 8. When we had 3 heads, 1 over 8. Now, if you add all this, you will simply get 8 over 8, which is eventually equals to 1. That is very critical. It's very important for all of us to understand. Let us look at example 5 and try to answer that question. And we are told that a tetrahedral die has the numbers 1, 2, 3, 4 on its faces. The die is biased. It's important to pick some words. I'll explain what biased means. In such a way that the probability of the die landing on any number x is the probability of landing on any number x is k over x, where k is a constant. Find the probability distribution for x, the number where x is, the capital X now, is the number the die lands on after a single roll. The die is biased. Biased means that all faces 1 to 4 are not equiprobable. They do not have equal probability of showing up. It is a biased die, and therefore the probability of showing phase 1 is not equals to the probability of showing phase 2, and so on and so forth until phase 4. Having said that, it is important to actually understand. Let us have a table here, because we have the small x, whereby we could have phase 1, we could have phase 2, we could have phase 3, we could have phase 4 showing up. And the probability, as we have just had, it is k over x. So when x is 1, so the probability of x is equals to x of showing phase 1 is k out of 1, because x is 1 here. Here we have k over 2, and here we have k over 3, and here we have k over 4. We have that kind of a table. So the question is, find the probability distribution of x, the number the die lands on after a single roll. Since we have now the probability distribution, and we know very well the probability distribution being shown on this table, we know the sigma of all the probability should always give us 1. Then it follows that the whole of this summation, that means k over 1 plus k over 2 plus k over 3 plus k over 4 should give us a 1. We have now to look for the LCM, where the LCM is 12. 12 over 1 is 12, times 1 is 12k. This is divided by 2 plus 6k plus 4k plus 3k is equals to 1. So all this, 12 plus 6 is 18, 18 plus 7 is 25k over 12 is equals to 1. And because we want to, first of all, get the value of k, it follows that if we multiply both sides by 12 over 25, then k is 12 over 25, because that will cancel out and we'll be left with 12 out of 25 as our value of k. Having said that, the question still is, we still don't have the probability, and now that we have found the value of k, the question is find the probability distribution for x, the number the die lands on after a single roll. What we were missing, or we were not having, was the value of k. Now that we have the value of k, we need now to talk about the probability of each and every value of x. And how do we go about it? Let us have the probability of 1 when we have x being equals to 1. When we have x being equals to 1, the probability is k over 1. Of course, k is 12 out of 25. This is the probability of x is equals to x, and that's where we are. When we have 2, the probability that when x is 2, the probability of 2 is actually k over 2. But k, what is k? This is 12 out of 25 times a half, which is 6 out of 25. That is the probability when we have phase 2, 6 out of 25. What about when you have x is equals to 3? What is the probability of 3? This is k out of 3, which is 12 out of 25 times, of course, a third, which is 4 out of 25. And the probability of showing a 3 is 4 out of 25. And finally, when we have a 4, what is the probability of having a 4? When x is equals to a 4, then the probability of 4 is given by k over 4, where k is 12 out of 25, divided by a 4, or times a quarter, which is by 1 by 3, by 4, 1 by 4, 3, it's 3 out of 25. And this is 3 out of 25. And that is now how we can simply answer that question. So find the probability distribution of x, the number the die lands on after a single roll. Meaning that because the die itself is biased, that all faces are not equal probable. They do not have equal chances. You can already see when we are having phase 1, this is the probability, which is different from all the others. Each one of the phase has a different probability, and that supports this statement that the die itself is already very biased, and that is it. All right.